The first sort we'll learn about is called selection sort. It's easy to understand. It sorts an array by making several passes through the array, selecting the next smallest item in the array each time and placing it where it belongs. So for simplicity, we'll illustrate all the sorting algorithms using an array of integers. Here's a trace of selection sort, where n is the number of elements in the array. So we have a for loop that ranges from 0 to n minus 2, and for each iteration we first set pos underscore min to the subscript of the smallest item in the subarray starting at subscript fill, and we exchange the item at pos min with the one at fill. So we start out with n equals 5. We set fill to be 0, and we look through the entire array and determine that the value 20 is the minimum number, and then we'll go ahead and exchange the 35 with the 20. So now we know that 20 is in its sorted position in the array. And next we'll start with fill equal to 1. We find the smallest element in the array and we switch it with position fill. So now 20 and 30 are in their sorted position. We start at index 2. The smallest value is 35. We swap that with 2, and so forth. Once we get to 3, that's in its sorted order, and now the array is sorted. So here's a trace of selection sort refinement. First we have where n is set equal to 5. We set fill equal to 0. We initialize posmin to point to fill. And now we look through the rest of the array. Every time we find a value that's less than the current posmin, then we will reset posmin. So now posmin points at 30. We'll continue our iteration. When we get to the end, 20 is less than 30, so posmin equals 20. So this is a little more refined, more specific algorithm about how we locate the smallest value. And then we go ahead and interchange them. And then this continues. So we'll set posmin initially to point to 65. Then we adjust it to 30 being smaller. The next two values we look at are larger. So finally, 30 was the smallest value. Then we start at index 2. When we find a smaller value, we'll keep adjusting posmin till eventually 35 and 65. We'll exchange those. And I will determine that 60 is in its proper place, and we're sorted. To analyze the cost of this algorithm, the inner for loop is performed n minus 1 times. And there are n minus 1 exchanges. So this comparison is performed n minus 1 minus fill times for each value of fill. So we can represent it by this series, n minus 1 plus n minus 2, and so forth. So this series, it's the well-known series that's n squared over 2 minus n over 2. So for a very large array, we can ignore all but the significant terms in the expression. So the number of comparisons is order n squared. The exchanges are order n. So it's an order n squared sort. And it's called a quadratic sort. Quadratic is the indication of the cost of the sort. So selection sort is easy to understand and implement. It's order n squared cost. Here's the code for a selection sort. Here's a template function called sort that takes a first and last or random iterators. And so we'll start at the first up until last minus 1. We'll increment fill each time. So each time for the for loop, the elements at positions first through fill minus 1 are sorted. And we'll set posmin to be fill. And here's the for loop where we will look to find the smallest value from fill up to n minus 1. And finally, once we've found the smallest value, then we'll go ahead and swap that they'll swap the values at pos, min, and fill. And here's the version of the function that has the comparison operator. And in that case, here we'll call the comparison operator. Notice in the last version, it was implemented using the less than operator. But in this version, we can pass in a custom comparison function, such as the example for person that we saw a short time ago. And then we'll go ahead and swap every time we find the smallest item. So here's the code for a selection sort for an array. So selection sort array, we pass an array and a size. Here's the for loop for each item in the array. We first find the smallest item, and then we go ahead and do a swap. If it's not if the smallest item isn't always the first item in the subarray that we're considering. And that brings us to the end of this slidecast.